Hello and welcome to HelpYourMath.com. We are going to look at question 13 of the Math 206.5 Final Exam Review. For these three questions, we want to find the exact value of each expression without using a calculator by using the properties of logarithms, so we better show our work. For the first example, we have log base 4 of the fifth root of 4. The first thing I might do is take that fifth root and rewrite it as an exponent that would be to the 1/5. So we would say log base 4 of 4 to the 1/5. And now I can say, well, my argument has an exponent. I can move the exponent to be the coefficient of this logarithm. That would be 1/5 of log base 4 of 4. But log base 4 of 4 just equals 1, right? Because this would be saying 4 to what power is equal to 4, and that would be 4 to the first. So log base 4 of 4 is equal to 1, and 1/5 times 1 is equal to 1/5, and that would be our final answer. I went very overboard with showing my work. You might not have to do every single step the way I did, but there it is all laid out for you. How about this example? We have the natural log of e to the -10th plus the natural log of e squared. This looks pretty scary, but really it's not, because the natural log and the natural base are inverses of each other. It's just like what we saw in the last example. We had log base 4 of 4. That's pretty much what this says. The natural log is log base e, so this is saying log base e of e to the -10th plus log base e of e squared. We can take those exponents and write them as coefficients. That would be -10 times ln of e plus 2 times ln of e, and then ln of e is equal to 1, so this would be -10 times 1 plus 2 times, again, ln of e is equal to 1, 2 times 1, and we end up with -10 plus 2, and our end result is -8. So all this scariness just for -8. One final example. This one probably looks the friendliest, but actually it's going to be the most work out of all three examples. We have log base 4 of 32. We want to evaluate this. We want the exact value for this. What I would suggest doing is, because 32 is not a power of 4, a nice power of 4 anyway, we might want to create an equation. So we're going to say log base 4 of 32. I know this is equal to something. I don't know what. I'm just going to say x for now. And now I'm going to put it in exponential form. So writing it in exponential form would be 4 to the x is equal to 32. And now what I might do is say, okay, 4 and 32 are both powers of what number? They are both powers of 2. So I'm going to rewrite them both to be base 2. I know that 4 is 2 squared, and I know that 32 is 2 to the 5th. So I'm just going to substitute in those powers of 2 for the 4 and the 32. I'm going to rewrite 4 as 2 squared. This is 2 squared to the x. And I'm going to rewrite 32 as 2 to the 5th. On the left-hand side, I have 2 squared to the x. That's the power to a power where I multiply the powers. We get 2 to the 2x is equal to 2 to the 5th. And now that we have the same base, and it's an equation, I know that the exponents must also equal each other. So I can say 2x is equal to 5, therefore x is equal to 5 over 2. So when it's all said and done, log base 4 of 32 is equal to 5 over 2. This has been question 13. Thank you for stopping.